we're going to go on to the next page. And water can change from a gas to a liquid. Water as a gas is called water vapor. So look at this cup. It is full of water, and the water is trying to escape out of the cup. And so they put a top to it, like saran wrap on top of it. And that saran wrap is not letting the water out. So the water is just going to come up to the top of it and get stuck because the water wants to evaporate and turn into a gas. Have you guys ever been at home and taken a shower or a bath and where you have your water in your shower in your bathtub and then all of a sudden it's really hot and steamy and it's turning into a what?
A smoke.
Kind of, not smoke, but gas. It's turning into water vapor. And sometimes on your windows, I know in our bathroom window or our mirror, sometimes it gets the droplets of water on it. So it turns. It turns
foggy.
Yeah.
It turns foggy.
Yeah.
Whenever we take a shower so long, it fogs up and we can barely see ourselves.
Exactly. So the water is turning to gas, and then sometimes it turns back to a water where it puts it on your mirror or on your window. And so that's what's happening here. Now, rain will freeze if the air temperature is very cold. Water on these leaves change from a liquid to a solid. And so we know that, except for maybe Eli. We know here in Minnesota, when it's raining and it gets below 32 degrees, that rain is going to turn into what, guys?
Ice.
Ice, and then what?
Liquid. Ice.
Ice.
Solid.
It's turning into solid ice, and then what does it even turn into after that?
Water.
Kinsley? It starts with an S, and we get it in the wintertime.
Snow.
Snow, yeah. So water coming from the sky in the wintertime will change from a liquid to a solid, to ice and then snow. Yep. Okay, now, heating matter. Heating can change the state of matter. Heat can change solids with liquids. Heat can change liquids to gases. Ice and snow melt when the air warms. Solid water becomes liquid. So think about us in Minnesota when we have snow in the winter, and then in the spring, our snow goes away. Our snow is a solid. Where does it go, Corla? Or did you want to say something? Okay.
So one time, we found a really stretchy glove, and we put a bunch of water in it, and then we tidied it up, and then we set it outside by our door, and then we let it enter.
Did you?
What was stretchy?
A stretchy bug, you said?
No,
Did it?
a stretchy glove.
Oh, glove. Okay, sorry, I thought you said bug there. And then you just let it sit outside, and what happened to it?
The water froze up.
The water froze the glove. So she said in the wintertime, she had a glove and it was full of water. And we know gloves are usually pretty, you can put your hands in, they're soft, they're stretchy. But it was full of water and you left it outside and then it turned hard, right? So it changed from a very soft solid to a very hard solid, didn't it? Good example. Now we know that snow is a solid, but in the springtime, what happens to our snow? Brooklyn?
It melts, but like last year, in the wintertime, we went ice skating and it's super fun. But my sister didn't know how to ice skate. But I learned like when we went to the ice wing last year. When we got home, I learned how to ice skate.
So it goes, snow will turn, some of it will evaporate into a gas, and some of it will melt into like the puddles of water that we see after the snow melts. So this can change from a solid to a liquid or a gas. Okay? Not right now, Charlotte. I'm not going to check it right now, okay? I'm busy teaching, but I'll check it in a little bit, okay? Now, your parents probably do this at home. When you boil water, the liquid water becomes a gas. This gas is called water vapor. So when they're cooking, you guys see that steam coming out of the boiling water or the pots? That's steam. That's not smoke or gas. That's not smoke, I should say. Okay? All right. Heat changes other matter from solids to liquids. Butter melts when you heat it. What are some ways that you can use melted butter? Do you guys ever see your mom and dad melt butter? Raylan?
All the time. What can you use it on?
Or what can you use it for?
Waffles? Corn?
Corn on the cob. Wyatt? Oil, yep. You need butter to use as like, sometimes this is kind of a special kind of oil that you can use it for. Kinsley? Is cloud a gas? It's water vapor. Yep. So basically it is kind of like a gas. That's what clouds are made out of, water vapor. Addie?
Maybe some, like, you know when you melt it and then like you put it on your mashed potatoes?
Yes.
Maybe you could use it for that.
Definitely. Yes, melted butter for your mashed potatoes. Brooklyn?
How come you can't breathe up above, like in the clouds? In the clouds, why can't you breathe?
Why can't you breathe up in the clouds? Because our atmosphere, we have really good oxygen right where we live, but the higher you go up, the oxygen that you breathe isn't very good. It's
because there's no trees up there.
well, kind of, but the level of oxygen as you go out of our atmosphere disappears. So like if you go out into space, there's no oxygen out there. So if you're an astronaut traveling, what are you gonna have on you?
I know it. It's like a little like shield and it's like oxygen that you like breathe into and like that gives you oxygen. And we went with my dad. We went up in the clouds in Colorado, and then we landed on the highest mountain in Colorado, and it was very fun. It was very, very snowy though.
And I'm gonna ask you, in Colorado, was it harder to breathe when you went up higher? I was going to say, because in Colorado is higher, especially in the mountains, than Minnesota. So if you're going to Colorado and into the mountains, some people think it's really, not really, but it's kind of harder to breathe. So that's a good example too. Wyatt?
I think, so like there's a big, like if you're in a plane above the clouds, there's like under all of the gauges and stuff, there's a big tank that holds oxygen, and then there's a pipe that leads to like a mouth thing, and then you put it on.
Right. So if you're in an airplane and you're getting like too high or something and you need oxygen to help you breathe, they do have oxygen on the plane. Okay, let's watch a quick little video. It's 4 minutes long, and then we're gonna have snack. This is on how matter can change from liquid to solids to gases, okay?
I have Mrs. Murphy, can I call me?
First, we have 3 things to say. Firstly, never snows in Arizona. Secondly, you can use butter for waffles.
Number 1, ice turns into bodies of water, sweltering day. Keep watching and you'll find out. On Earth, materials exist in one of 3 main states of matter: solid, liquid, or gas. Materials can change between these states. When a state change occurs, a substance's property will also change. Maybe not too surprising. However, if the state change is reversed, the substance will recover the properties it had to begin with. Neat. Matter can transition between the 3 states when heated or cooled. But why is heat key in all of this? When a material is heated, it absorbs heat energy. This additional energy can cause attractive forces between molecules to break. This leads to rearrangement of the particles because the attractive forces no longer hold them together as tightly. The same happens when a liquid is heated. The attractive forces between the molecules break, leading them to become more widely dispersed and a gas to form. These four words describe changes in state. Do you know which word refers to which change? Pause the video, fill in the gaps, and click play when you're ready. Did you get them right? Do you know the difference between evaporation and boiling? Both are when a substance transforms from a liquid to a gas. Think of a boiling pan of water. All of the water bubbles. This is because all of the particles have enough energy to become gaseous. But water standing in a pan that is not being heated by anything other than the environment can also turn into a gas. This is evaporation. Only the particles at the surface have enough energy to change from a liquid to a gas. Hence, evaporation is a slower process than boiling, even though it achieves the same state change. Both are types of vaporization. The opposite of these vaporization processes is condensation, the transition from a gas to a liquid. Think of a cold can of soda on a hot day. Those water droplets on the outsides, or the dew on the grass in the morning, or the steamed up mirror after a hot bath, even the clouds in the sky, or a foggy windscreen in a car. These are all examples of condensation. Water vapor in the air has cooled down to form liquid droplets of water. Now let's think about the transitions between solids and liquids, so melting and freezing. Think of the Arctic sea ice. In the summer, when air temperatures are warmer, more heat energy is absorbed by the ice. This causes bonds to break between the ice's water molecules, and the ice starts to melt. The solid ice becomes liquid water. But in the winter, the air temperatures are colder, and so seawater freezes, and the ice starts to form again. There is less heat energy within the ice, and so more bonds can form, holding it together as solid ice. So far, so good. But did you know that sometimes when solids are heated, they can turn straight into gases? This is called sublimation. This is only demonstrated by particular materials such as solid carbon dioxide, also known as dry ice. When subjected to a certain pressure, it will turn straight into gaseous carbon dioxide. Liquid carbon dioxide does exist, but it only occurs under very high pressures. Similarly, gases can turn straight into solids when cooled. This is called deposition. Let's check out how much you remember about the changes of state. Pause the video and fill in the blanks. Did you remember them all? Our final thing to discover is that when a material changes states, the mass stays the same. The density changes, so the mass per unit volume, but the mass does not change. Our glass of nice cold Coke weighs the same whether the ice is solid or when the ice is melted. So there we have the changes of state. Just remember that the mass stays the same whatever the state.
Did you guys know that? So if you have an ice cube in a cup of water, the weight to that is the same as whether that it's a solid or if it's a liquid. All right. Louis, you do